This is a simulation on a website called PhET, physics, and we're going to simulate friction of a crate. This is a 100 kilogram crate, and we're going to do an applied force to it, which we can change right here. That's the orange color, and then the friction is the red, and that's F of F, which is a negative direction, opposes motion. And we can demonstrate how this moves with respect to the friction. So I'm going to go back to the beginning here, and if I put 490 newtons of force on this and push play, it's not going to go anywhere. That's not enough force to get it to budge. Now when you're sitting there, the friction is called static friction. You're not moving. So I have 490 newtons of static friction opposing my 490 newtons of applied force. So my sum of my forces is 0 newtons, and I have no acceleration, no velocity, and I'm sitting there right there at negative 10, 8, 6, 5, 4, 2, 0, etc. My meters across the bottom. So in order to get it to budge, I've got to go higher than this 490. I'm going to increase it to 494 at 2 seconds. And so bam, I just increase it to 494 and it begins to accelerate. So at this point, the force, you can't really tell there, but the force was increased from 490 to 494. It's a pretty small bump right there, so real hard to tell. But what happened is actually the friction dropped. This is called kinetic friction. This is called static friction. Kinetic friction is friction when something is moving. It's actually less friction when you're moving than when you're sitting still. So static friction is more, and as soon as it budges, it just got to budge, the friction drops. And so this is kinetic friction. And so now it's actually a little bit easier to move than I might have thought. So this is actually 494 minus 294 gives me a net force of 200 newtons. That's positive. Since this is a 100 kilogram crate, 200 newtons divided by 100 kilograms gives me 2 meters per second squared. So my acceleration here is 2 meters per second squared. This is a slope of 2 meters per second squared, and this is a curve. The curve says that I am going faster and faster with respect to my position. So I'm going to increase like that for 2 seconds, and then at 2 seconds, what am I going to do? I'm going to now try to see if I can get it to go at a steady rate, a constant velocity. And so this area here, which is a straight line, represents constant velocity as opposed to the curves, which represent acceleration. This velocity is increasing, this velocity is constant, and of course in a moment I'm going to slow it down. So what I did with my forces is now my net force is back to 0. If my net force is 0, then my acceleration will be 0 as well. So this is a 294 Newton force, a negative 294 Newton force of friction. These two are now equal in size, and my net force is 0. I have 0 acceleration. So now I'm going to slow it down, but I want to slow it down and stop it at the same rate as before. So if I'm going to increase at a 2 meters per second, that would be positive 200 newtons divided by 100 kilograms gives me a positive 200. So now I want a negative 200 as my net force. So if I put this as 94 minus negative 294, or added to negative 294, will give me a net force of negative 200. And right there you'll see 94, negative 294 gives me a negative 200, an acceleration of negative 2. And so my velocity will begin to slow down until I come to a stop. And once I stop, the friction once again turns back into static friction, and it opposes my motion entirely, so I cannot move. So that is the force, acceleration, and velocity and position graphs. What you should do now is come over to the right and click on here and choose something else to do, maybe a sleepy dog or a refrigerator, and do it on your own. Push that sleepy dog and see if you can make the same graph that we just made here.